First of all, let's see some basic concepts of inequalities. So if we have one inequality, let's say a is greater than b, taking some example, it's 5 is greater than 2. Now if we add something on both the sides, the inequality, if you see, remains same. Okay, so question is, will it always remain same? Yes. So it's like both the sides are getting increased by the same amount. It could be both the sides getting decreased by same amount. The inequality will remain same. It won't change. Okay. So in inequality equations, mostly what's our concern is whether the inequality sign would change or it will remain same. Now take one example. Let's say given is a plus 5 given bigger than b plus 5. Okay. Compare it with equality. Now in equality we could cancel if there is something on both the sides. So the same thing can be done with inequality also. It's like subtracting 5 from both the sides. Okay, so what we're left with a is bigger than b. Okay, don't make the mistake of this. If it is positive 5, it is negative here, then we can't cancel. Okay, the sign should be same. It's a minus 5 greater than b minus 5, we can cancel. It's like adding 5 on both the sides. Okay, so we can write a is more than b. Same way, if a is greater than b is given, okay, it's like we can take b to this side. Let's say we subtract b from both the sides. Okay, so it's as good as taking b to this side. So we can do that perfectly fine. No problem with that. Again, let's say some inequality is there. 6 is more than 2. Now if I multiply both sides by something, it remains same. If we divide both sides, still remains same. This is one example. Now if I multiply both sides with negative number or divide both sides with negative number, now if you see, the inequality would change here. So minus 12 minus 4 minus 4 is bigger. The inequality sign gets reversed or gets changed. Same here, minus 1 will be bigger than minus 3. So if the number by which we are multiplying or dividing, if that is positive, the sign, inequality sign, would remain same. But if it is negative, then it will get reversed. So it's like ax is bigger than bx. Now we divided both sides by x, let's say. What we're left with is a and b. Now do we know whether x was positive or x was negative? No. Okay, so when we have a variable, we can't divide both sides. Or we can't multiply both sides because we don't know sign. If it is positive, the sign would be this. If it is negative, the sign would be changed. So that's a problem. So ax more than bx is there, we can't cancel out. That'll be wrong. Cancelling out means we are dividing both sides by x. So we don't know whether the sign of x is positive or negative. We don't know what will happen to the inequality. So that's the problem here. Okay, if it is given that it is positive or negative, then obviously we can, divide both sides. For example, if I say 2a is bigger than 2b, now we know 2 is positive, we can cancel, or we can divide both sides by 2. Okay, we can't divide by variable, that'll be wrong. Let's take one example. So is x minus y plus 1 greater than x plus y minus 1? That's the question. Now remember, in most of inequality questions, we can simplify the question stem itself. Now, can we subtract x from both the sides? Yes. Okay, or it's like cancelling x from both the sides. Now, what are we left with? Minus y plus 1 greater than y minus 1. We can take y to this side. And now we can take 1 to this side. Okay, we are simplifying the question. So is 2 greater than 2y? Now we can divide both sides by 2 is 1 greater than y, okay, or is y less than 1? That's your question now. If you see first statement, it talks about x, we don't even need x, not sufficient. Second one says y is less than 0. The question was, is y less than 1? So if y is less than 0, it will definitely be less than 1. So this is sufficient. B would be our answer. Let's see one more. MV is less than PV is less than 0. So both are negative, that's given to me. Is V positive? First statement, M is less than P. Now if we multiply both sides by V, let's say we multiply both sides by V. Now do we know what happens to the sign? See, otherwise we don't know, okay, but it's given in the question itself. MV is less than PV. That means the sign, the inequality sign, it remains same. That means the number by which we multiply should be positive. Okay, we multiply both sides by V something and the inequality sign remains same. That means we must have multiplied by a positive number. That's the only conclusion we can make. Sufficient. Second statement, M is negative. Now given is, if you see, M into V is negative. The product of two numbers is negative. It should be one positive, one negative. Okay? They should be of opposite signs. Right? So M is given as negative. That means V must be positive. The other number must be positive, so that the product is negative. So from here also V is positive. That's a conclusion. This is also sufficient. D option is your answer. Is P square Q less than PQ square? Now one mistake people make here is divide both sides by PQ, so we are left with P less than Q. Okay, now that's a problem, because we can't divide both sides by PQ. No, we don't know whether PQ is positive or negative, so we don't know whether the sign would be same or not. We can't say. Okay, so first statement says P into Q is negative. Now in this case we know the sign of PQ. Okay, it is negative. So I mean, be it negative or positive, the point is, do we know the sign or not? Now we know. That means we can divide both sides by PQ now. Okay, so if we divide, what happens? The question becomes, is P greater than, I mean, it will not be greater than, and if we divide both sides by PQ, what we are left with is P and Q. Okay, and because PQ is negative, we divided both sides by a negative number. That means the inequality sign would get reversed. So that becomes your question. Okay, I repeat, we divided both sides by PQ. We're left with P and Q on both the sides, and because we divided by a negative number, the inequality sign would get changed. Okay, so that's your new question, but I don't have answer to this question. Okay, so not sufficient. Second statement says P is less than 0. This itself is not sufficient because we have no idea about Q. Q can be positive, negative, anything. Q could be 0 also, so we don't know what will happen. Combine the two. P into Q is negative and P is negative, so Q should be positive because the product of two numbers is negative. Now in first statement, when we divide both sides by PQ, the question gets reduced to, is P less than Q? Okay, now we know P is negative, Q is positive. So if P is negative, Q is positive, negative is always smaller than positive. So that is sufficient to conclude. Okay, In first question, the concern was, or the question gets reduced to, is P less than Q. That problem is taken care of by second statement, because it says P is negative, so Q should be positive. So that's the conclusion. C would be your answer. Is M greater than M? First statement, N minus M is greater than negative 2. I mean, we just took 2 to this side, or we subtracted 2 from both the sides. So how should we take this thing is, let's take some numbers first, like 4 minus 5 is equal to minus 1, and that is greater than minus 2. So in this case, N is less than M, and it could be 5 minus 4 equal to 1 greater than minus 2. I mean, 5 and 4 will also satisfy it, and in this case N is bigger than M. So this is not sufficient. How should we understand this thing is, we subtracted one number from another. Difference is more than minus 2. More than minus 2 means it could be negative also, it could be positive also. So the difference is negative, that means it's smaller number minus bigger number, like here. If the difference is positive, it will be bigger number minus smaller number, like here. So we don't know out of M and N which one is bigger or smaller, so this is not sufficient. Second statement, if you see N minus M minus 2 is greater than 0, taking 2 to the side, greater than 2. Now difference is more than 2, that means difference is positive, so it has to be bigger number minus smaller number. So N is greater than M for sure. This is sufficient. We know out of M and N which one is bigger and which one is smaller. Is 2x minus y minus 3y less than x square? First statement says 2x minus 3y. I mean, the left hand side is a negative number. Now x square will be either 0 or positive, it can't be negative. So the left hand side, which is negative, is always smaller than square of something. Definitely sufficient. Second statement, x is greater than 2. Let's say x is equal to 3, 4, such numbers. In this case, x square will be greater than 2x for sure. Okay, 3 square is bigger than 2 into 3. So all the values of x greater than 2 would satisfy this thing. Now it says y is positive, so 3y will also be positive. So now if I do 2x minus 3y, so 2x will be bigger than that. So x square we can conclude is bigger than 2x minus 3y. This is also sufficient. Let's see this question, x plus y. What we're concerned with is x plus y, is it less than 1? First statement tells me x is less than 8 by 9, doesn't tell me anything about y, not sufficient. Second statement tells me about y, doesn't tell me anything about x, not sufficient. Combine the two. Now see, ultimately what we need is x plus y. One equation is x is less than 8 by 9, another is y is less than 1 by 8. When the inequality signs are same, we can simply add the two equations. So wherever you see two equations in inequality, we can simply add them if the inequality signs are same. So it becomes x plus y less than 73 by 72. Now the question is it less than 1? Let's say this is 1. Now 73 by 72 will be slightly bigger than 1. This says x plus y is less than that. But it can still be more than 1 or it can still be less than 1. So both conditions can still happen. So even combination is not sufficient. E would be your choice. R plus S bigger than 2t is R greater than t. First statement, t is bigger than s and R plus S is bigger than t plus t, 2t. That's given in the question itself. Again, two equations, same inequality, we can add them. R greater than t sufficient? That's the question. Second, R greater than S. So R plus S greater than t plus t, that's given in the question, this one. So 2R is greater than 2t. We can divide both sides by 2 because 2 is positive. R greater than t, this is also sufficient, d. Is m plus z positive? Okay, so the way we need to understand is sum of two numbers positive? So if both the numbers are positive, the sum would be positive, and if both the numbers are negative, the sum would be negative. Okay, so before getting into values of m and z, we need to first get into the signs of m and z. Okay, first statement, m is greater than 3z. Now if I say one number is bigger than another number, can I say whether both of them are positive or both of them are negative? No, it's just that one is bigger than another. They can be both positive, both negative. Not sufficient. Second, 4z is greater than m. Same situation, one number is bigger than another. They could be both positive, they could be both negative. Clearly not sufficient. Combine the two, m minus 3z is positive, 4z minus m is positive. Two equations, same inequality. So we can simply add them. Z is positive from here. Now if you put it in first statement, m is bigger than 3z. Now if z is positive, 3z is also positive. That means m is also positive. M positive, z positive, the sum would also be positive for sure. C is your answer. Now is x into y positive? Product of two numbers, is it positive? Now if x and y, they have same signs, it will be yes answer. And if x and y have opposite signs, I mean one positive, one negative, it will be no answer. The product would be negative. First statement, x minus y is greater than minus 2. Now if you see, it could be 6 minus 5 greater than minus 2, both positive. It could be 6 minus minus 5, that will also be bigger than minus 2. In this case, I mean one positive and other negative. So this is not sufficient. Same goes with second, x minus 2y is less than minus 6. So it could be 4 minus 15 less than minus 6. Or it could be minus 4 minus 15 less than minus 6. So they might have same signs. I mean same signs here. They might have opposite signs here. So not sufficient. Combine the two. Now two equations, but the inequality signs are same. If they're different, if you see. So what we can do is, we can multiply the second one, x minus 2y less than minus x, both sides by minus 1. What happens by that? So if we multiply both sides by a negative number, the inequality sign changes. So now this is your first and this is your second statement. So what we get is y is more than 4. So more than 4 means y is positive for sure. If we put it in first statement, x minus y is greater than minus 2, so x is greater than y minus 2. Now if y is more than 4, so y minus 2 will also be positive. So x is also positive, y is also positive, so x into y would be positive. This is also sufficient. C is your answer.